everybody ready to kick us off with the best presentation of the conference. Everything's going to be downhill from here. Okay, just kidding. Good morning, everyone. Welcome to SDC 2024. I am Rochelle Olvers, the chair of the Scalable Storage Management Twig that produces the Swordfish specification. I'm also the chair of the Storage Management Initiative, which provides education and promotion for storage management in general, and the vice chair of SNIA. Oh, wait, all that stuff's here. And in my day job, I work for Intel. What we're going to talk about today is kind of just a little bit of a refresher on what Swordfish is and what's been going on with that. The rest of our track today is building a little bit on that. We're going to have Jeff Helen come up and talk about what's going on with Redfish, and then we'll have a couple of other presentations talking about just some other use cases and the like with Swordfish. All right, so is there anybody here that's never heard Swordfish before? If so, what rock have you been under? My comedians in the front row, my other presenters. All right. Just a little quick recap, right? So what are redfish and swordfish and how are they related? We just kind of trying to recap a little bit on this. One of the weird things we've been running into lately is that people are like, and I wanted to kind of highlight a little bit on this as I talk about what is redfish, swordfish, how are these things related? Because this is a little bit of an overview here, just a few minutes on this, is sometimes when you're seeing redfish, you're actually seeing swordfish lately. So just kind of wanted to highlight a little bit about that, and in what cases, and then where, what have we been adding, and then we'll hand it over to the next folks. Oops, I've got to pop up on my own screen here. So Redfish is really a very broad-based management standard. Jeff's going to come up next and talk about a bunch of the features that they've been adding into that will also apply to Swordfish. But it's really looking at how do we provide this really unified interface for managing a wide range of the IT infrastructure, right? All of the server-level details, network devices, fabric management, CXL, looking at data center infrastructure management, working on power management, working closely with OCP, lots of lots of very physical focused infrastructure, but by and large, they leave the storage pieces to us and they partner with us on this. So it's not different. Swordfish really is the extensions. So I'm going to talk about that a little bit here because this is where I think there's a lot of confusion about Swordfish is a different thing. No, Swordfish is not a different thing. It's not even, sorry. Allergies are kicking up a little bit here. Swordfish is really truly an extension. Parts of our schema are distributed and tightly integrated with Redfish. Pieces of it are delivered with Redfish. You will actually even see the Swordfish schema bundles describe the Swordfish functionality. That's what we'll kind of highlight here a little bit this morning, and then talk a little bit more about some of the more storage-centric use cases. So we'll start here. This is one that is, purely Redfish, right? You have a basic Redfish system. It's just got a local SAS drive attached. There's actually no Swordfish in this picture. So you start with you got a system, and I know this one gets a little tiny. That's what you get for sitting in the back, and by the way, if I wasn't presenting, I'd be sitting way in the back too. You get servers. Let me see if I can grab a pointer. You get the servers that sit under your systems, and your chassis view systems is your logical representation. Your chassis is your physical representation. This is not fully populated, obviously. But under your systems, you get, I really should switch this to a view where I can see bigger. You've got BIOS, you've got Ethernet interfaces, you've got memory, you've got processors, and then when you get down to the storage piece, you've got under here, so server/storage, you've got just a couple of things, right? This is a really simple representation to get a SAS drive in here. You've got storage, there's actually an embedded storage controller kind of thing in here, and then you've got volumes and drives, and then those drives are, in this case, if you go look at the mock-ups online, this original representation didn't even show those drives as part of the chassis. They're really just attached to that system, right? So very simple representation. Well, okay, that's a SAS drive. We're all migrating to and using much more complex systems. So what happens if I stick an NVMe device in there? Well, I'll walk you through some of the more complex configurations here. There's many, many, many different potential models for NVMe devices. So starting back in 2020, 2019, NVMe, SNIA, and DMTF started working together in a three-way alliance on putting together Redfish and Swordfish models for managing these devices. So we don't just say Swordfish models here, we say Redfish and Swordfish models here. This was a Swordfish-led, a SNIA-led initiative. Most of the work happened inside the SSM twig in SNIA. We developed the documentations. The schemas are in both the Redfish schema pack and the Swordfish schema pack. So you will see a lot of the schemas that we talk about here show up in Redfish schema, and then some of them show up in the supplemental Swordfish schema bundle. The documentation is all on the SNIA website. So, like I said, it's very tightly coupled. So you'll see information about this everywhere. So just saying, I'm going to do NVMe, just Redfish, isn't really what you're doing. You're actually doing both of them. So it's not like, it's not a big leap to say, okay, I'm going to go add Swordfish. You're already doing it. Okay, so there's three kind of big pieces of information on the SNIA website. If you go to snia.org/swordfish, you will find the model overview and mapping guide. You'll find the NVMe over Fabrics white paper, which is, if you're looking at NVMe over Fabrics, really, really useful white paper there. And then you'll also see a bunch of profiles, which I'll talk about as I get through a bunch of this. I'll highlight, I have one slide in here I'll talk about. For the offline version of these slides, I'll go back and put some additional information in here to give it a little bit more context for anybody looking at that. Just to kind of give a comparison of what kind of information's in the profiles. So if we say, okay, we saw that really simple SAS model, what is a Redfish system with NVMe drives? Where is that Swordfish content? So in second half of 2020, and if you even go back and look at the Redfish schema bundles, it's 2020.3 is the corresponding version of that. It shows exactly the same corresponding link. Swordfish added jointly with Redfish this level of support, right? We moved all of this infrastructure and added the documentation with the beginning of the mapping guide. Swordfish moves, anytime you want to see storage information, whether it's NVMe or not, you want to find it, you find it easily, you add it to its own location on the service route, /redfish/v1/storage. So if you have NVMe drives in there, if you have standalone, if you have whatever, you're all gonna be able to find them easily here. So we offload the drives to here. If you have a NVMe device model, you have namespaces, You have subsystems. If they're very complex devices, then you add storage pools to model endurance groups and sets. If you don't have those, if they're just implicit, you don't model those. If you have domains, you add domains. Any additional level of complexity get added under that /storage instance. And so all of those additional models that additional complexity is all in those Swordfish extensions. So if they're not, then they're in those common models. So storage is mapped to the, subsystem is mapped to the storage object, which is a Redfish storage controller is mapped to, the I/O controller, discovery controller, and admin controllers are mapped to the storage controller objects so that we can have a common controller for non and regular. And then volume is actually a Swordfish-owned object that Redfish pulls in. So hopefully you can see how these are all nicely linked and play together nicely. All right, so on to adding complexity, right? So we then leverage the Redfish fabric objects. We've added similarly a bunch of extensions and extended use cases in, and then we push the schema back to Redfish for access management. So there's NVMe specific properties in these. When we're doing access management, that covers we use the connectivity model, which is connections, endpoints, and zones. Access management uses connections, endpoints, and zones. Connectivity uses switches, endpoints, and zones, all under the fabric model. For other use cases, we go back and we've added NVMe-specific properties into those controllers, into the storage controller model. And all the documentation for this is on the SNIA site. And the schemas are on the Redfish site. So you can, again, see that tight partnership. So where do we document the details there? So the details then are in the profiles. So if you have implementations that you want to say, how do I know what specific properties to implement, you can look both in the mapping guide for how to understand exactly what properties to implement or how to implement a specific property. But then you can look in the profile to see what specific properties to implement. So for example, on the NVMe drive, actually let me start here because this one's a very simple set, right? I want to know if this device supports Swordfish. So we have a construct called a features registry. And the features registry says what Swordfish features do you implement? And this one basically says, I support Swordfish. And so there's really 3 or 4 different things you have to implement here. You have to say, I support this basic Redfish protocol version. I have a storage instance we just talked about in the service route. I support, in that storage instance, I have the volume collection. There's not actually a requirement there's anything in it because there's a lot of use cases where you may not have, again, on that NVMe side, you may not have a namespace created at various points. And that's it, plus that features registry. For the NVMe drive, we have a relatively comprehensive list of required properties. So if you want to say, I am an NVMe drive, I support this, we have a long list of properties that you need to implement. There's also a list that says, don't implement these, which is just as helpful as saying the list you need to implement. So there's properties in both drive, storage, and storage controller that need to be implemented. Similarly, if we expand beyond NVMe, we have properties such, or profiles such as I/O performance. This gives a requirements for how we show performance-specific metrics behavior. And what this will do is, again, it's got a dependency that says you got to support swordfish discovery. That tells us you're supporting swordfish basics correctly. And we saw how simple that one is. And what this one does is then says within our metrics and telemetry service infrastructure, what you need to do is support an object we call I/O statistics. And I/O statistics is a blob of rolling counters. And within that, and so you need to support that rolling counters blob for any volume storage pool file system or storage service. And those are supported within the volume metrics, storage pool metrics, and so on and so forth objects within those devices. And if you do that, then you can say, yep, I support that. So that's kind of how the profiles are structured. And at this point, we are, if folks come in with implementations and want to see tweaks to those profiles, want to see new profiles created, we're happy to work with that. We're in the process of working with OCP on getting some of these put into the OCP storage hardware profiles. So you can hopefully expect to see some of those show up within the next few months as the basis for some of the OCP hardware profiles for storage. Okay. So what else is new? I know I said I'd get to what's new. We're getting there. Some of the new things that we've been rolling out, we're really in a very incremental phase right now. We're just responding to requests for incremental functionality. We haven't had a really big new set of features other than aligning a lot of the functionality to NVMe 2.0 C lately. And then adding a bunch of new features. So we've been adding some of the bigger chunks that have come in lately that drove the 1.2.7 release was the configuration lock for storage subsystems and drives. What this is basically the lockdown feature in NVMe up-leveled. So what we did was we took that lockdown feature, up-leveled it to a general purpose configuration lock feature that's applied across both the storage subsystem, which is, the storage object, and then the drives. And so it basically has 3 different properties that work together. So this can be applied across different technologies right now. It's fully instrumented for initial implementation for NVMe, and full implementation details are in the NVMe mapping guide. And here's just a little snippet of an example of how that works. But you basically have the configuration lock, which tells you, is it enabled, disabled, or just partially set? Partially set is just really a reflection that it hasn't been set. It either hasn't been set correctly or it has never been enabled on that device. And then right now we only have the only thing that's actually been configured is a baseline configuration. So if folks have requests for other configurations, then we can start adding those into the schema. We've also added a couple of new white papers and guides in. We've added an interoperability guide. I was talking about those profiles. The interoperability guide fully details both our interoperability behaviors as well as all the profiles we have, how to use them, specifics around them, and a bunch of additional information. And then we've also this year, since the last SDC, we've added the Swordfish and NVMe over Fabrics white paper. Later this year, we'll have some updates coming to that one. Was there a question? Yeah.
Is there any access control for the configuration?
No. The ACL, there's no more access control on configuration lock than on any other property within the system. So you will have
So once you grant an access to do anything in Swordfish or in Redfish, you can do configuration.
yeah, so it's basically the same read-write control you would have. So if you have, administrator access, if you're set up as administrator, you would have, the ability to do the config lock. If you are if you're a read-only user, you wouldn't be able to patch it. So it's gonna be using the privileged model for basically whatever privilege model is set up for the rest or set up for the service. And then on the back end, it just maps on NVMe. It's going to map to the lockdown command on the device. So all of those are set up to go control the out-of-band interface. So. Okay, and then where to find more info? Oh, sorry. On the, one other note on the NVMe over Fabrics white paper. This details information about both just the overall NVMe over Fabrics, as well as a lot of the new information that was in TP6011 and is being integrated into the overall NVMe over Fabrics behavior. So things like exported file systems that were used to be logical exported file systems that are now logical file systems or exported file systems. I forget which word they dropped. So all of that information about that is somewhat documented here, but it also translates. The thing we're adding that we'll be adding later this year is an explanation of how to do all of the configuration control of that in Swordfish. So we have some discussion of that now, but we'll be adding like how that maps to use cases and what the workflows look like, which is, of course, what you care about when you're looking at it from a Swordfish perspective. All right, any other questions? So I think we are, yes, sir.
A lot of infrastructures these days are using Prometheus for information gathering, and I think even Prometheus has the API access. How does this compare to that, and is there an overlap between these two?
Chris?
Prometheus needs an AI to talk, or needs a REST API to talk to. So Prometheus is great for gathering information using an API, but it's not the API you're talking to. It's the thing that talks to the API. This is the API.
So Prometheus can be the discovery and information provider for this.
Now, this would be what Chris is saying is that Prometheus would need an interface to talk to. This would be the interface that it would talk to. So if you want a standards-based interface for Prometheus, Redfish and Swordfish would be the interface to connect Prometheus up to, so that you don't have to teach it every single device's proprietary interface.
And to go along with that, we have examples like the Datadog example, where we've had somebody actually
Yes.
use the Swordfish API to feed information to Datadog, because you can feed it to Grafana, you can feed it to Datadog, you can feed it to Prometheus, whatever you want to feed it to, it can go.
All right, and with that, I am out of time. So thank you very much.